Okay, hello everyone. In this video, we are going to solve a problem from Codeforces. It is from Codeforces round 792, and the problem name is MEX versus difference. It is rated 2100 on Codeforces. Okay, so in this problem, uh, you are given an array A of size n. In one operation, what you can do is you can change any number in the array to any other number. Like if the array contains number, let's say 13, then you can change 13 to any other number that you want, but it should be non-negative, like it should be greater than equal to 0. Okay, and here is the definition of the cost of the array. What does this definition say? This says the cost of the array is difference of the array minus max of the array. So since you are solving 2100 rated problem, I think you must be aware of what do we mean by max. So max is just minimum excluded number. This is the smallest non-negative integer that is not present in the array. Okay, and here difference of a means the number of different numbers in the array, like how many unique numbers are present in our array. So let's say this is your array. So here how many unique numbers are present? One is 4, and one is 13, one is 0. This 0 is repeated, so we will not count it. This 13 is also repeated, so we will not count it. And this 1337 is unique, and this big number is also unique. So there are just 1, 2, 3, 4, 5. 5 is the number of difference. 5 is the value of difference of a. And what will be max of a here? Max of a is the minimum non-negative number which is not present in the array. So non-negative numbers starts from 0. 0 is present in the array, but 1 is not present in the array, so the max of this array will be 1. Okay, here is another example of how to find max. Okay, I don't think there much be any need of explaining this. Yeah, so what the problem says that you need to minimize this cost, minimize this difference minus max value, where you are allowed to do at most k operations. Okay, so the constraints on n and k are up to 10 raised to power 5, and constraints on the elements are up to 10 raised to power 9. And yeah, okay, so let's see an example and then we'll try to figure out the approach for this problem. So I'm taking example number 3 first. Okay, so let's come to iPad. Okay, so yeah, so my example says n equal to 7, k equal to 2, and our in numbers are 4, 13, 00, 13, 1337, and something very big number. Okay, it is 1e9 something, but it doesn't matter. It is 1e9 or 1e6 or anything. Okay, so here we are given two operations, and we need to minimize difference of this array minus max of this array. Okay, so the solution says you can the solution says, okay, solution is not explained for this problem. Okay, let me explain it. Why did I lose? Okay, I'm sorry, I did lose the connection. I don't know why, but okay, it is back. So yeah, the okay, why am I losing my iPad connection? The operation could not be completed. Give me a second. Why did I lose my connection? I don't know. Okay, my iPad is not showing. Let me fix it. I will be back. Yeah, okay. So we are back. Let's see. Let's hope we will not get another timeout. Okay. So yeah, what we can do in this problem is, let's say for the first, uh, we are provided with at most two operations. So let's say in the first operation, what I do is I change this 13 to 1. So my array becomes 1, 137 and 1 is 6. Okay, and in the second operation, what I do is I change this 1 to 2. So our array becomes this. Can you find like I have exhausted all my operations. So here can I find difference of a minus max of a? So here max of a will be 3 because 0, 1 and 2 are present in our array, but 3 is not present. So obviously max of our array will be 3. And what will be the difference of our array? Like, difference means how many unique elements are present in our array. So this is unique, this is unique, this is unique, this one is not unique, this one is unique, this one is unique, and I think this one is unique. Okay, so there are 1, 2, 3, 4, 5 and 6. There are 6 elements that are present uniquely. So here our answer becomes 3. Okay, is there any better way to do our operation such that answer gets minimized, like answer becomes less than 3? Fortunately, yes, there is difference. There is another way where you can solve this problem and your answer become less than 3. Okay, so let's see. Our original problem was 41300. Let me see on the Codeforces again. 41300. Yeah, 13, 1337 and 1E9 or 1E6 something. Okay, so here what I can do is I can make this in the first operation. I can make this k as 1. I can make this 4 as 1, and our array becomes this. And in the second operation, I can make this 1377 as 2. So here our array becomes 2 and 1 is 6. Now you can, if you see here, difference is 1, 2. Difference means number of unique elements. Number of unique elements are 1, 2, 3. This one is not unique, this one is not unique, 4 and 5. So difference of a is 5, and max is again 3 only. Because we have 0, we have 1, we have 2, but we do not have 3. So here what is our answer? Answer is just difference minus max, that is 2. And you cannot minimize it to 1 or 0, or like 2 is your answer. Okay, so first of all, where anytime when you see problems like this, that you have to minimize or maximize or do something, on two variables. Like here our first variable is difference and second variable is max. Okay, so here what we have to do is minimize this relation, difference of a minus max of a. So one general technique of solving this kind of problem is like, obviously you can just iterate for all the differences and all the mix, and you may get any algorithm that solves the problem in O of n square complexity, where you are iterating in for every difference and for every mix. Okay, but obviously O of n square will not be feasible for n equal to 1e5, so this is not the correct approach. Yeah, So one of the thing that you must notice in this kind of problems, that if you fix a quantity, like if you fix difference or if you fix MEX, then you only need to iterate on the other quantity, no? Like if you fix that, yeah, my MEX is fixed, then I only need to minimize or maximize a difference. Like some of the times you have also solved this kind of problem, that you need to find number of pairs I comma j such that there is a relation like input of I, like array of I minus array of j is minimize or maximize or something. So in that problem, in those kind of problem also, what you do is you either make I constant and iterate on j, or either make j constant and iterate on I. So if you make a particular quantity fix, if you fix one particular quantity, then you only need to iterate on another quantity, and that will be in order of n only, because iterating one variable is order of one kind. Okay, so in this problem we will also be doing the same stuff. Okay, so let's say that our optimal, like if you have the problem, if you have this as your initial array, and I said you, okay, what will be our final array? That final array will be having MEX equal to, let's say, something k, like not k, here k is already a variable, so let's say p. So I said that in our optimal answer, our MEX will always be p. Okay, so now can you find, like, how will you rearrange, like how will you be using your operations such that your answer will be minimized, such that answer is minimized. Like let's see, uh, like in both this example, our MEX was 3. Okay, in the first solution where our answer becomes 3, our MEX was always 3. Like not always, in this problem our MEX was 3. In the another case also, our MEX was 3 only. But what happens, like here I have used another kind of operation and I get the answer 2. Here I have used some another kind of operation and I have get the answer 3. So a particular value of MEX can have different answers if you use your operation in some different ways. Okay, so first thing first, before jumping anywhere, okay, I think I again got the problem. Let me again wait. Let me again modify it. Okay, sorry for the interruption. I am things are fixed and I am back again. Okay, so what I was saying is, let's say I have said that, okay, your final optimal answer will have MEX equal to p. Then how will you use your k operations such that your final answer diff minus MEX is minimized? Okay, so let's see how will you do this. So like here in this problem for 1300, 13, 1337 and 186, I have said, okay, let's say my final MEX is 3. So in this I already know that there must be three places where I must be having 0, 1 and 2. Because if I do not have 0, 1 and 2, then how would our MEX will be 3? This is the point now. Like if I am not having any of 0 or any 1 or any 2 in our final answer, then how can our MEX will be 3? So we must have any 0, any 1 or any 2 in our MEX. Okay, I'm not sure like why my iPad is giving time as 9:41, but it's actually time is 2:17 only. So there may be some problem with my iPad. That's why my stream is also crashing. So okay, no problem on that. Okay, so sorry for the off topic. Okay, so I was saying for MEX equal to 3, we must be 0, 1 and 2 in our final array. Okay, so we already know that 0 is present in the array. So what I have to do is to convert any number to 1 and any other number to 2. Yeah, that's how I will get 1 and 2 in our array. So how to choose those number is the critical point. Like in the first operation, I have chosen this 4 and this 13. This 4 and this 13 I have chosen, and I have got the answer as 3 in by these two numbers. In the second operation, I choose this 4 and this 1337, and I got the answer as 2. Okay, so why is this problem? Okay, so let's see. You have choices. You have what are the choices you have? Let's not update a single 0, because we need a single 0, no, we need a 0 also. So why do I want to just waste my k to, let's say you say okay, make this 13 as 0, this 0 as 1 and this 0 as 2. So like why do I want to do that? This will just waste my k, because if I already have a 0, then why will I make any other number as 0 to satisfy my MEX? Obviously I will not. So just leave this 0 as it is. Now I am left with 0, this another 0, 13, 1337, 1 is 6, and this 4 and 13 also. I am left with these 6 numbers, and I have to choose 2 numbers, and I have to make those 2 numbers one as 1 and one as 2. So how will I choose those 2 numbers? Okay, 4, 13, 0, 13, 1337 and 1 is 6. How will I choose 2 numbers from here to convert one first number to 1 and second number to 2? Okay, so let's see. You said okay, choose 113 and 14, what I did in the first trial. Okay, so if I choose 113 and 14, I converted this to 1 and 2. So what I see that okay, my MEX was to fix. My MEX was just 3, and it will be always 3 whether you choose this 2 or this 2 or this 2 or this 2, anything, because I have fixed. I am trying to find out the answer for a fixed MEX. So my MEX is fixed, and if I choose 4 and 13, then I got that okay man, 4, 13, 0, 2, 1336 and 1 is 6. All these 6 numbers become different. So in this array my difference becomes 6. I'm sorry, my difference becomes 6. But if I choose okay, if I say no, choose this 4 and this 1337, which I did in the second approach. So here my difference becomes, how many numbers are different? 1, 2, 3. This one is same as before, 4 and 5. So do we not want to minimize our difference? Like our answer is difference minus MEX. So either our MEX is maximized or our difference is minimized, then I will get the minimum answer. Is it true or not? Like if we have to minimize the quantity difference minus MEX, then obviously we have to either maximize MEX or minimize difference, or both of them simultaneously. So here our MEX is fixed, so I have to minimize the difference. So to minimize the difference, why would I choose that number that has already no contribution in difference? Like let's say here 13 are 2 times, and you said okay man, choose 113. Then if you choose 113, then this will become a number that is not already in the array, like 1 or 2. So this will become another unique, and this will become another unique. So our difference will be maximized. So why will I choose that number that is already duplicate? So I should not be choosing that number. Okay, so what I will do is out of all these remaining numbers, I will just sort them in such an order that the number which is not unique, like number which is not duplicated, this is not duplicated, this is not duplicated, although this 0 is duplicated, but this 0 is not duplicated here, but this 0 is part of this two numbers, no? So I will just ignore it as well. So here I have 1, 4, 13, 13, 1, 3, 3, 7 and 1 is 6. So if I choose this number, this will not affect my difference, because this was unique 4, this was unique also, and if I change it to 1 or change it to 2, then also it will just remain unique, so there will be no change in our difference. But once I choose 13, then our difference gets increased by 1. Reason being that this 13 was not not contributing to my difference earlier because of this 13, but as soon as you change this 13 to 1 or 2, then this 13 was already contributing, this will be now also contributing, and this one will again contribute to my difference, so my difference will increase, and that is a wrong thing. No, I want to minimize my difference, because I want to minimize my difference minus MEX, and MEX I have fixed here, so I just want to minimize the difference. So what will I do? Okay, so the crux of my approach is, if I fix a mix, then I will just take all the numbers, like let's say all the numbers that are like let's say in a general example, my mix is let's say 8, okay, and there are some numbers that are less than 8 and some numbers like 9, 10, 13 that are greater than equal to 8. These are the numbers that are greater than equal to 8, and these are the numbers that are less than 8. So I do want that, okay, 0, 0, 1, 2, 5, 6, 7, this must be in our array, in our final array. So I am not going to I'm not going to like I'm not going to update it, or I am not doing operation on this, okay, but I want that these numbers must be converted, like if I need here 3 and 4, yeah, if I will get 3 and 4, then the mix of this array will be 8 only. So I said, okay, if I need 3 and 4, then I will convert these greater than equal to 8 numbers to 3 and 4. Like let's say here are 9, 10 and 3 times 10, then 11, then 12. Then I will convert some of them to 3 and 4. I will choose two numbers from here and convert them to 3 or 4. Okay. So now how will I be choosing those two numbers? So I will be choosing those two numbers on the basis of their frequency. Like I am not choosing 10 here. Like if 10 is, if I choose any of the 10, then this 10 will become 3, let's say, and earlier this 10 was not contributing to the final answer, as this 10 was already duplicated from this, but now this 10 is already contributing, and this 10 becomes 3, and it will also contribute to our difference, so our difference will just become +1, and this is what I do not want. So I will say, okay, I will say just sort this array on the basis of its frequency. Like let's say I am sorting this as this. Now I say, okay, I need two numbers, I will just take first two, okay, because these first two are the least frequent numbers in the array, in the greater than equal to mix part. So I will choose the least frequent numbers that they were like this number was contributing 1 to the difference again, difference before, and let's say I am making this 3, then it will again contribute only 1, so it does not affect our answer. Let's say you said, okay, what if the condition was this, if you choose 9 also, then it will make our difference plus plus. Yeah, but still this is better, no? Like if you choose 12 also, then again you are getting difference plus plus, because if 9 is duplicated, then also every number are duplicated. So for the general, without the loss of generality, I'm sorry for the pronunciation, generality, yeah, why the without the loss of generality, I will just say okay, I will sort the array on the basis of their frequency, and take I will take numbers from the starting. Okay, so yeah, this was the case when you fix the mix. You said okay, my mix is fixed, and I will choose those numbers which have the least frequency in greater than equal to max part. Okay, and let's say you say maybe I do not have those kind of numbers which are greater than equal to max. Like let's say my array was 0 0 0 1 2 3 4 5, let's say this, and our max is here, I said that max will be 8. So you said, boss, I need here 6 and 7, but there are no greater than equal to 8 numbers. So how will I choose 6 and 7? Your theory will fail here. No. The answer is okay. In this case, earlier 0. In this case, 0 and this 0 was not contributing to difference because these two are duplicated. But let's say you change this to 1 and sorry, this to 6 and this to 7. So because of this, like let's say earlier your difference in this array, your difference was 6 and max was also 6, so answer was 0. And if you said okay, I am making this 6 and making this 7, so again if you say that your final array become this, and your difference is 8 but your max is also 8, so your answer is again 0. Like changing earlier numbers will not affect your answer, because if you increase the difference by the same amount, your max will also increase. Like if you made this any of these numbers as 1 6 or 7, then your difference will increase obviously, because there was no 6 earlier, but you have made one number as 6, so your difference will increase. But same goes to your max also, your max will also increase, here your max was 6, but as soon as 6 comes, your max becomes 7, so your max will also increase. So at the end, your answer will again remain the same. So what I am trying to say is I need to just update, I need to just choose numbers from I need to just to okay, I'm sorry, I need to just choose numbers from greater than equal to max part and not less than max part, which less than max part will not affect my answer. So I just need to choose numbers from greater than equal to max part. Okay, so now here is the point. Like okay, like here I said I have done all the things for a fixed mix, but the main problem is how do I fix this mix? How do I fix this mix? Okay, the crux of the problem is how do I fix this mix? Okay, so I am, let's say I am saying a thesis that my assertion is higher the mix, better the answer. Like I am saying, just choose the highest mix possible. Okay, you will say why? Like why is this true? So let's say your array was something 3 9 6 or anything, like you say 3 7 9 8. Here your mix was 4, and you said okay, and let's say k equal to 1. So you said, boss, what I am trying to do is let's say I said okay, your mix was 4, I am like I'm not able to generate answer from this example. So let's say something in general. I'm saying that okay, your answer was I'm saying that higher the mix is better the answer. You said no. This how do I prove it? Okay, so I am saying in two examples, like one is mix minus 1 and one is mix. So if I find the answer for mix minus 1 and find the answer for mix, which one will be better? I said the answer for mix minus 1 will be I will have all the numbers from 0 to mix minus 2, and I will not be having mix minus 1, and I will having some other numbers as well. Okay, like let's say mix minus 1 was 5, mix was 6. So I was not having 5 and I was having some other numbers. Okay, and here the difference minus mix is what? Difference is 0, 1, 2, 3, 4, 5, and 4 number here, 5 either. This was 9 minus mix was here mix was 5. That comes out to be 4. Okay, and if I say okay man, what you do, you just change one number to 5. I just changed one number to 5. So can you see, like if you change one number to 5, then there will be increase in max as well, like your max becomes plus 1, and either difference will decrease or difference will remain the same. You like if you choose the number from this part, then either difference will just remain the same, because if you choose to decrease, if you choose to make 6 5, then earlier it was 6, now it is 5, so it will not affect your answer. But mix is great, mix becomes plus 1, so you just want to minimize the difference minus mix value, so you just want to maximize the mix possible. Like if mix plus 1 is possible, then you should choose it over mix, because your answer will be minimum when mix will be maximum. Okay, so this was the case, that you need to maximize your mix value, so you just choose the highest mix possible. And you cannot say that okay, it may be possible that for a given max, difference was, let's say difference was diff, and for max plus 1 difference becomes diff plus 2. This will not this is not possible, because at max for max plus 1 difference will become diff plus 1, but this will not affect your answer. No, like max difference is increasing as well as max is also increasing, so difference minus max is just same as before. This can never happen that your max increases by 1 but your difference increases by 2. This is not possible, because either you will choose number from right hand side of max, then that number will be, that if that number is unique, then that number will just your difference will just remain the same. And if let's say that number was duplicated, like here this, and this 6 was duplicated, and you choose this 6 to become 5, so here in this case your difference just increases by 1, but your mix also increases by 1, no? So the finally difference minus mix value is just the same. Difference minus mix value is just the same. 1 minus 1 becomes 0. So this was the core logic of this problem, that you choose the highest mix possible. You choose the highest mix possible, and for that highest mix, you solve the problem by choosing least frequent numbers from right hand side. Okay, so yeah, I think I am pretty much this problem is over now. So if you want to dry run, if you want me to dry run for a problem, like let's say I am doing a dry run for this problem only, and 26. Okay, so first of all, how will you find that which is the highest mix that is possible? So let's say you said okay, you just sort this number first, sort this array first, and you said okay, if I say the highest mix is possible, like we cannot have max greater than n, no, like if we have n numbers then highest max is only n. So I said okay, is n minus 1, is n possible, is max equal to n possible? I said okay, for max equal to n I do need here n is 1 2 3 4 5 6 7. I said okay, for max equal to 7 I do need 0 1 2 3 4 5 and 6, but I do have only 0, so I need in this array I do have only 0, so I need at least to change 6 numbers, 1 2 3 4 5 6. I need at least 6 operations to make this change. Do I have 6 operations? No, I do have k equal to 2 only, so no, max equal to 7 is not possible. Similarly, you will check for max equal to 6 5 4. Let's say for max equal to 4 you checked, so for max equal to 2 you do need 1, max equal to 4 you do need 1 0 1 2 3 in your array, but you only have 0, so you said I need at least 3 operations to make any of these numbers to 1 2 and 3, and you said no, I still do not have sufficient amount of k, so no, max equal to 4 is also not possible, but for max equal to 3 it is possible. For max equal to 3 you need 0 1 and 2, you already got 0, you just need to change any of these two numbers to 1 and 2 and you do have 2 operations. So yeah, max equal to 3 is possible. So you will just focus on how to choose your operations for max equal to 3, because this is the highest max that is possible. Okay, so yeah, that's how I got the answer for mix. I got the answer for mix. Now I am fixing the mix equal to 3 is fixed. Now I am saying okay, less than 3 part is here, greater than equal to 3 part is here. I need to choose two numbers from this 1 2 3 4 5 numbers, and I need to convert them to 1 and 2. Okay, so I'm saying I will choose on the basis of their frequency. I will sort this number on the basis of their frequency. Like 4 has only one frequency, this 3 has only one frequency, so these 3 will come first, then 13. And now I will choose 4 and 1 3 3 7. It doesn't matter whether you choose 4 or this or this or this or this. You just need to choose the best amount of numbers. And since I have sorted in increasing order of their frequencies, then I will just choose starting k numbers. So I have chosen starting k numbers, made them 1 and 2, and so our array becomes 0 0 1 13 13 2 and 1 is 6, and our final answer will be difference is 0 1 2 3 4, yeah, total 5 unique numbers, and max is 3, so my final answer is 2. Yeah, so yeah, this was the pretty much logic of the problem, and now I'm going to walk through my code. So okay, so the first thing I'm taking input and k, this is all the input part. Okay, I am taking the input and making a set for only the unique numbers. Okay, and then I am putting all the unique numbers in another vector. In this block of code, I am finding the maximum max that is possible, and I am storing that in arithmex. Okay, so I am traversing from n to 0, and as soon as I get a max that is possible, I will just break from this loop. Okay, so for any I am finding how many smaller elements are there. In chote means smaller, so I am finding how many smaller elements are there in the array, like, and not duplicates, like unique uh, elements. I have taken only unique elements in this V, no, like I have taken this I have made this V from this set, so the V contains only unique elements. So I am I am finding lower bound of for this mix, for mix equal to I. How many numbers in this array is less than I? Okay, let's say, and I also have to decrement my counter, because lower bound will give greater than equal to number. So for less than, I am decrementing my index. Okay, so these chote numbers are the numbers that are less than equal to my number. Okay, if you are not able to understand this, I can show you with a dry run also, like the same example for 1300 13 1337 26. Okay, so let's say for I equal to 5, our V is always 0 4 13 1337 and 26. It is sorted and only the unique elements are present in our V. Okay, so I equal to 5, my lower bound will pointing to here, and for chote I just need to, for smaller number I just need to make this chote minus minus. Here I am doing the minus minus for just make lower bound pointer one before. Yeah, and how many more I need? How many more I need? I need 0 1 2 3 4. I need 5 elements. No, for this mix I need 5 elements, but I have only got 2. So how many more I need? 5 minus 2, and 2 is what? 2 is just the pointer index that I am at, and plus 1, like it is 0 based index, so this is 1. So 5 minus 2 is just 1 plus 1. Okay, so that is I am doing I minus chote minus 1, like I minus this is this, and this is plus 1. So yeah, if you open the bracket, this becomes I minus chote minus 1. I think you can, if you have any problem, you can just take a dry run by yourself and you can just figure out this thing. Like, this is not a big deal. If you are solving 2100 related problem, then this is not a big deal for you. Okay, so if I have that much amount of operations, like if my k is greater than equal to how many elements I need, then actually I can make the whole array, my final array, with this required max. So I will just say required max is I, and I will break from the loop. Okay, now I have fixed my required max. I am trying to find my answer for that required max. So for all the elements that are greater than equal to required max, I make their frequency, like what I was saying. I make the frequency of all the elements that are greater than equal to required max, because I don't need to make change for the elements that are less than required max, because they will not affect my answer. Only my answer will be affected by the numbers that are greater than equal to required max. Okay, so for all the numbers I just made their frequency plus plus, and I just put them into a vector, and I just sort the vector on the basis of their mapping. Like here my CMP function is set. Okay, and the element having the less frequency will come first, and if they are equal, then just return anything like a less than b or a greater than b. That does not matter. Okay, so I have sorted on the basis of frequency. Then while k minus minus and I less than v2 minus h, v2 is the final answer, that final array that is sorted on the basis of frequency. Okay, and I have started a pointer with I equal to 0, and while I have the operation or my pointer is less than v2, I am just incrementing my pointer. Okay, so either k becomes 0 or my pointer goes out of the size of the array. Okay, and if let's say my pointer has not gone out of the array, okay, here I need to explain something more. Okay, let's say our mix was 3 and I had the array is 4 1337 1a6 13 and 13. I need to choose two numbers, so I was saying, okay, start I from here, and while k minus minus, like it will iterate till 2 times. So I am just taking two numbers and I have made them 1 and 2. 0 was already there, so I have made them 1 and 2. Okay. Now the number of elements that are left in our array. Now what is the difference of our array? So the difference of our array is our mix. Like if mix is 3, then there are at least 3 numbers that are unique, 0, 1 and 3. So how many unique numbers are there in our array? 3 from mix, and remaining elements will contribute to difference as well. Like this will contribute to 1, this will also contribute to 1, this will not contribute because this is duplicate. So how many unique elements? Unique elements are mix plus unique elements of remainings. What do we mean by remainings? Remainings means like first 2 numbers I have converted to 1 and 2, and what are other remaining number? Just find out how many unique elements are from those remaining elements, and they will contribute to our total unique numbers. So I am just doing that thing. Like if my I is not exhausted and some numbers are remaining, like there may be case no ki I do have k equal to, let's say, 10, and I had only these numbers 1, 13 and 13, and for after 5 operations our our array becomes empty, but still I have left with some k operations, like some 5 operations. So I basically don't need to do these 5 operations. Like I have said that I am doing at most k operations and not exactly k operations. So yeah, just don't do these operations. So yeah, no problem in that. So if I'm saying okay, if there are some elements remaining, like if for j equal to I and j till less than v2, if there are some elements remaining, then put those elements into my remaining set, and the size of the remaining set is the number of elements that will be contributed from that side. Okay. Now let's say what is my answer. I said okay, my difference will be mix plus unique of remainings. Unique of remaining is I will get as size of remaining set. Okay, and what will be our answer? Answer will be difference minus mix. So just minus mix. So our answer will be just size of remaining set. So this is what I am doing. My answer is just size of remaining set, and I am just printing this answer. Okay. Yeah, this was the whole logic and code of this problem. So if I for a quick recap, I think I should give you a quick walkthrough. So first thing was you have to minimize the answer, then you just maximize the mix, because the maximum mix will have either better answer than its previous mix or equal answer than its previous mix. It will never be the case that mix equal to 4 is giving better answer than mix equal to 5. It will not be possible. Either both will give same answer or 5 will give better answer. Okay, this is the tricky part. Like you can think why is this. I have tried to explain why is this not possible. Like previous mix is giving better answer, but you can also think it by yourself by taking by taking 2-3 examples. You will be eventually able to figure out. Okay, and the next thing, that if you had found a particular mix, then you have to find how to choose your operation such that you minimize this difference. So for that I have told you that first of all, choose numbers from greater than equal to max part. Don't choose numbers from less than max part, because those are the numbers that you will require. Like for max equal to 8, you need numbers from 0, 1, 2, 3, 4, 5, 6, 7. And why do you want to change this number 3 to something? Like why? You always require 3. then you just leave it 3 there. You should not be changing less than max part, you should be changing greater than equal to max part, and on the basis of their frequency. Because if frequency is less, then they will uh, either make the difference same or just make the difference a little positive. But if you make if you change a number that was much frequent, then their every duplicate will become another unique element. Like you have 13 13 13 13 and you have 9 9. Then if you change these three, then these three will become another unique numbers, 1 2 3, let's say. Initially this whole 13 set was contributing 1 to uniqueness. Now these whole set are contributing 4 to uniqueness. But if you change this only to 1, then there is only 2 unique numbers. Okay, and there are 4 unique numbers. So you should sort the array on the basis of frequency, and then you can choose starting how many numbers you want to complete your mix. Okay, so this was the whole part and the whole code. I think I will be uploading the whole code in the description box. So yeah, you can take a reference from there also. Okay, thank you. We will meet in some other set of questions. Okay, bye.